Hello students, welcome to this class of fluid mechanics. So as we had discussed in last class, until now we have discussed about ideal fluid, right? We have not studied about viscous forces. We have considered the ideal situation, however that was a hypothetical one to ease our analysis, because every fluid has some viscosity associated with it, more or less, but every fluid is viscous. So there will be some energy losses due to viscosity, right? But until now we have studied Bernoulli's equation, right, momentum equation and all that, but nowhere we have considered the viscosity of the fluid. Okay, but now we will proceed towards real situations. Okay, we will consider here but the actually how fluid behaves actually. Okay, what's the impact of viscosity on velocity, on the shear stresses and all that. Okay, so first of all, what was Newton's law? Newton's law of viscosity, remember? Viscosity, it states that tau is equal to mu du by dy, right, where tau is shear stress and mu is coefficient of dynamic viscosity, okay, and du by dy is the rate of shear strain. This is the Newton's law of viscosity. Fine. Now because of viscosity there must be some loss in energy. See, this is shear stress. From here you can calculate force. Fine. By knowing the area you can calculate force, that is drag force, or you can say that drag force. Because of viscosity, each layer will resist the flow of another layer, right? So there will be some drag force, that is resistance to the motion of fluid. So because of that resistance, some energy will lost by fluid itself in overcoming its own resistance, right? That was not considered until now. In Bernoulli's equation we have not considered such losses, but yeah, losses are there. Okay, so we will see from now on that how those losses are taken into account while using the equations in fluid mechanics. Okay, so before moving forward, first of all we need to know what is Reynolds number. Okay, just a basic idea, we will study about it detail in further also. What is Reynolds number? First of all, this is a dimensionless number. Okay, this is a dimensionless number, that is it has no dimensions. Okay, and what's the significance of Reynolds number? It is used to classify lamina and turbulent flow. Okay, used to classify laminar and turbulent flow. Basically, if the viscosity is high, fluid is called laminar in nature. However, if viscosity is low, it generally shows turbulent behavior. We will see how. Okay, so first of all, let's write Reynolds number for pipe. Okay, for pipe, Reynolds number is equal to rho d v by mu. Okay, or I can say that d v by nu, where rho is density, okay, d is dia of pipe, v is velocity of fluid, okay, and mu is dynamic viscosity. And what is this nu? This is dynamic viscosity upon rho, which is called kinematic viscosity, right? This is kinematic viscosity. So this is value of Reynolds number. Now for pipe flow, if Reynolds number is less than 2000, okay, if Reynolds number is less than 2000, it implies laminar flow. It implies laminar flow. Okay. However, if it is greater than 4000, it implies turbulent flow, and in between it's a transition flow. So you can see Reynolds number is inversely proportional to dynamic viscosity, right? Inversely proportional, that is, more the viscosity, less is the Reynolds number, which implies it will tend towards laminar flow, okay, which also implies that high viscosity fluids generally has laminar flows, okay, generally shows laminar behavior. However, low viscosity fluids generally shows turbulent behavior, okay. High Reynolds number means the behavior of the fluid will be turbulent. However, lower viscosity means the high viscosity means the flow will be laminar. However, lower viscosity means the flow will be turbulent. Okay, so this was the basic. Fine. And yeah, here V is the average velocity. Do keep it in mind that V here, that is velocity of fluid. This is average velocity. Okay, this is not the instantaneous velocity. This is average, that is Q by A. Q is flow rate, A is the area. So this is the average velocity at any cross section which we are studying. Fine. I hope you got the idea about viscous flow. Now from next class we will see what are the equations for the velocity and shear stress for pipe flow when viscosity is considered, and what is their profile. Okay, we will discuss some relations for pipe flow as well as for parallel plates. In next class we will study about pipe flow. Okay, well, see you in next class. Bye bye.